Use multiplication or division to find the first three non-zero terms of the function y equals e to the x times the natural log of 1 plus x. Using the power series expansion given in table 1, we know that e to the x is 1 plus x squared over 2 plus x cubed over 3 plus x to the 3 factorial, x to the 4th over 4 factorial, and so on. I don't know how many of these we need, but I'll just write down a few of them. And for the natural log of 1 plus x, we have x minus x squared over 2 plus x cubed over 3. That doesn't really look like an x. Minus, and that certainly didn't look like a minus, x to the 4th over 4 plus, and so on. Again, I don't know how many terms we need. We'll just see how this plays out. What we're going to do is the world's worst FOIL problem. So I'm going to distribute the 1 to the terms that I can see inside of the parentheses on the right. And then we'll distribute x into the terms that I can see in the parentheses on the right. And just to continue on, next would be x squared over 2, distributing into the terms that we can see in the parentheses on the right. And we'll see how many terms we need as we go. But in fact, what I'd like for you to do is go ahead and pause the video and write down a few terms of the product. I've written out a few terms of the product. Distributing the 1 gives us x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. Distributing the x gives me a positive x squared minus x cubed over 2 plus x cubed. That should be x to the 4th over 3. And then distributing x squared over 2 gives me x cubed over 2 minus x to the 4th over 4. We could go on, but see, we were asked for the first 3 non-zero terms. Why did we do more than we needed then? Well, as you can see here, we have x cubed over 2 and x cubed over 2. One's a plus and one's a minus. If it weren't for this x cubed over 3, these would zero out, and then I wouldn't have 3 terms. So I generally go for a little more than I need so that I don't have to go back and recompute the products. But here what we can say is we were only asked for these. Simplifying these will give us x plus 1/2 x squared plus 1/3 x cubed. Those are 3 non-zero terms in this product. Next, same instructions. We're going to look at y equals the secant of x. We're supposed to use multiplication or division, and so it would be good to envision the secant of x as a quotient or a product, but a quotient is what makes sense here because the secant of x is the reciprocal of the cosine of x. So we're going to take 1 and divide it by the cosine of x, which according to table 1 is starts out as 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Now we start our division. 1 divided by 1 is going to give us 1. And after we divide, we multiply and subtract. So multiplying is going to give me 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. Notice I only wrote down one minus sign there. It's because I didn't want to do a whole lot of erasing. We're going to subtract the whole thing, and so actually everything is going to end up with opposite signs from what it had. So negative 1 plus x squared over 2 factorial minus x to the 4th over 4 factorial, and so on. After we have added now, because we've already distributed, we see that 1 minus 1 will subtract out. We're left with x squared over 2 factorial minus x to the 4th over 4 factorial plus x to the 6th over 6 factorial. And if it turns out that we don't have 3 non-zero terms at the end of this, we can go back and revisit how many terms we wrote down to begin with. Now we're at the point where we're going to divide x squared over 2 factorial by 1. Remember, when we divide the first term by the first term. And so that's going to give me a plus x squared over 2 factorial. And now we distribute and change the sign so that we can add. Multiplying and changing the sign then gives us negative x squared over 2 factorial plus x to the fourth over 4, because 2 factorial and 2 factorial are each 2, and then negative x to the sixth over 2 factorial times 4 factorial. Of course, the first term subtracts out. Folks, if you're ever doing long division and that doesn't happen, you have done something wrong. Now let's turn our attention to the second term here, negative x to the fourth over 4 factorial plus x to the fourth over 4. 4 factorial is also known as 24, and so I can see that we need to multiply numerator and denominator of the second fraction by 6. Therefore, we're going to have 6x to the fourth minus x to the fourth over 24, and so this difference then becomes 5x to the fourth over 24. We could continue on here, but I can see that I'm about to end up with the third term, which is what I was asked for. So I'm going to kind of weasel out of this and just put plus stuff. And then dividing the first term, 5x to the fourth over 24, by the first term of the dividend, 1, is going to give us plus 5x to the fourth over 24. Those are our first three non-zero terms.